We know what is integration. What is integration? Where we are going to perform this integration? Integration and economic. So derivations and integrations అనేవి ఉంటాయి కదా,
మ్యాథ్స్ లో అవుతాయి.
మ్యాథ్స్ లోనే. సో కంప్యూటర్ ప్రోగ్రామ్ అనేది వన్ పార్ట్ ఆఫ్ మ్యాథ్స్ నో. ఇన్ ఆర్డర్ టు సాల్వ్ ద మ్యాథమెటికల్ ఈక్వేషన్ ఆన్ కంప్యూటర్ ఇస్ నోన్ యాజ్ ప్రోగ్రామ్ నో. సో ఇన్ దట్ వాట్ ఈస్ ద డెరివేషన్ కి ఇంటిగ్రేషన్ డిఫరెన్స్ ఏంటి? డెరివేషన్
ఇంటిగ్రేషన్ లో సింప్లిఫై చేసేస్తుంది సార్ ప్రాసెస్.
ఇంటిగ్రేషన్ simply you can do addition. We are going to be add. So their integral from one limit to another limit, we are going to be perform on a particular function, how it is going to be done. So if you know that, for example, if I ask from 0 to 2, if I said the limit is 0 to 2, if I said how we are going to be substitute the limit in the function, ఫస్ట్ లోయర్ లిమిట్ ని చేసి తర్వాత అప్పర్ లిమిట్ ని చేస్తాం కదా, ప్లస్ చేస్తాం కదా, గుర్తుందా? సో వీఆర్ గోయింగ్ టు బి పెర్ఫార్మ్ ఆపరేషన్ అండ్ ఫర్ ఎగ్జాంపుల్ ఎఫ్ ఆఫ్ ఎక్స్ అన్నామంటే ఎక్స్ ప్లేస్ లో ఎక్స్ యొక్క ఇంటిగ్రల్ 0 to 2 అన్నామంటే 0 వాల్యూ 2 వాల్యూని మనం సబ్స్టిట్యూట్ చేసి ఫైనల్ వీఆర్ గోయింగ్ టు బి కంక్లూడ్ ద ఆన్సర్ బై యాడింగ్ అప్పర్ లిమిట్ లోయర్ లిమిట్ యాడ్ చేసి మనం చేస్తాం. అంటే ఏంటి, పర్టికులర్ 0 నుంచి 1 వరకు లేదా 0 నుంచి 2 వరకు, 0 నుంచి n వరకు, 0 నుంచి ఇన్ఫినిటీ వరకు, వాట్ ఈస్ ద వాల్యూ ఆఫ్ దట్ వన్, హౌ we are going to be find out. So here we are going to be see about this message integrity. The cryptography system that we have studied so far provide security. Simply we can use security or confidentiality, but not integrity. So what is this three things? Security, confidentiality, integrity. What is the three things? The first chapter we studied that the triangle thing it mentioned. So one side is a security, another one is a confidentiality, another one is integrity. No? So that is the three things. So far we didn't discuss about the integrity. However, there is an occasion where we may not need the security, instead of we must have included integrity. So wherever we don't need a security, in such place we are going to be included this integrity concept, then we are going to be. So what are the main sections in this? So documentation, fingerprint, message and message digest. So very important one, message digest. Then another one is about differences. Then another one is checking the integrity and cryptographic hash function criteria. So next chapter will be 11th chapter is about message integrity, and the 12th chapter is about hash function. Okay, the first one is about document and fingerprint. What is the meaning of this one? One way to preserve the integrity of a document is through the use of fingerprint. If Alice needs, you know that terminologies, no? Alice, Bob and Eva. Alice, Bobs are the sender and receiver. Eva is the third party person, is going to be trying to theft the data from the Alice. So Alice needs to be sure that the content of her document will not be changed. She can put the fingerprint at the button of the document. What is the simple meaning of a fingerprint? For example, even if mobile also we have a fingerprint. So how the mobile is recognized, exact fingerprint is matching, then your mobile is going to be unlocked. No? Same like that. If the Alice is sending that, the document, no one not going to be change it. So third party person అనేది చేంజ్ చేయకుండా ఉన్నారనేది Alice నమ్మాలి. So in such place, Alice needs to keep a fingerprint on this document. Okay, so that is the meaning. So the electronic equipment of the document and fingerprint pair is the message and digest pair. See that? So we are sending a message and we have message digest, message and message digest. How it will be? For example, if I have a document, how we are going to be perform this message digest. So message digest is nothing but a fingerprint. So in between we are going to be add some hash function. We are going to be perform this operation. So this is the message. Applying a hash function on this, then we can get message digest. Message digest is nothing but a fingerprint. General normally we have physical representation lo manaki electronic equipment use chestam. But in a document is a digital format, how we are going to be perform these digital fingerprint operation means through the message digest we are going to be get this fingerprint operation. Okay. So the two pairs document or fingerprint and message or message digest are similar with some differences. The document and fingerprint are physically linked together. The message and message digest can be unlinked separately, and most importantly, the message digest need to be saved from the change. So it should be keep it as very safe in order to other third party person should not change that one. So note the message digest need to be safe for change from change. So we need to keep as a safe. So how it will be? I will show you one simple data how the message digest is going to be done. So wait a second. So I will show you how the message digest is going to be. I will show you 1 second. So my screen is visible to everyone. So can someone answer?
No, sir.
Now it is okay.
Yes, sir.
See that message integrity here we are going to be learn. What is the message? The word of security communication. Message integrity describes the concept of ensuring that data has not been modified in transit. What is the meaning of transit? So we know the data is transferring through the network, no? That is known as the transit. So even the Alice and Bob are sender and receiver, even with terminologies we may use. The both have to think that the sender sended the exact message which the receiver has received. The same thing that the receiver will think that the exact message is sending by the sender only. So there is no modification done in between in the time of traveling the data through the network. It should not be modified. This is typically accomplished by using a hash algorithm function. So what is a hash algorithm also I will show you now itself. Now we can take a look into the actually what is a message integrity provides. The basic premise is the sender wishes to send a message to receiver and wishes for the integrity their message to be guaranteed. The sender will calculate the hash on the message and include the digest of the message. On other side, receiver will independently calculate the hash. So yesterday, in the last class we discussed. So it is not like encryption and decryption we said, no? So it is not a reversible process. So same here only. Here also. So independently calculated the hash just as a message and compare the result of the message digest when we send the message, which send the message. If there is a same, then the message must have been same from the original sender. See here, the diagram is visible to everyone. The moving parts. The sender is
Yes,
sending
sir.
along with hash. Now after hash, the message and hash is going to be sent. Then again the separate hash is going to be calculated by the receiver. See now, message and hash is sending. Then hash is going to be calculated by the receiver separately. Then the calculated, independently calculated hash function and the sender received hash function is going to be compared. If both are equal, then only the receiver confirm that the original message has no modification. That means no other third party person not yet enter into that message and did not change. So now I will show you from the starting onwards. We are saying what is the message digest, what is the meaning. See here. So some hashing algorithm is there. See that? So I have a message, hello. So, okay, I will read it once again. The first concept we need to discuss our exploration of cryptography, that is a hash algorithm. Hash algorithm is a mathematical formula that takes a message of arbitrary length as the input and proceed as the output. So my screen is visible.
No, sir.
Now it is okay.
No, sir.
Now,
Yes, sir.
okay.
Yes, sir. Yes, sir.
Some little bit problem with the network. Once again, need to keep charge. Okay, see that slide. If, definitely, we will understand what is that message digest and how the hash algorithm is going to be performed. See that hello text is there. Hello text is there. Some message that is known as a message here. Hello message is there. Then hashing algorithm is going to be calculated. What is this? Can you anyone observe what is the 8 plus 12 plus 8 plus 5 plus 12 plus 12 plus 15? Can anyone say that what is that?
Individual letters.
Maybe you can say that the letter number. Okay. So ABC we have 26 now. In the 26 we have giving a letter. So how we can say that now? For example, L is 12 means another L is 12 now. Same. We can identify that how it is same. So here also see that, and downside also LL is considered as 12. So A, B, C. C is the third letter now. So that is the third. See here, for instance, that repetitive example, hashing algorithm, simply adding upon the letter values, particular A equal to 1, B equal to 2, and so on, like that. So hello is a message, 8 plus 5 plus 12 plus 12 plus 50. So total is about 52. That is the digest. So by hashing algorithm, we are going to be do the message digest. So the result of hashing algorithm is called message digest, or sometimes we can check checksum. So in the last class message authentication, we saw about this FPSC now. So same, whether it is checksum or fingerprint, whatever it may be, we can call. The result of our example hashing is the original message is hello was 52. Hello was 52. Someone, if somewhere they change our original message and process it through the some hashing algorithm, and resultant will be gives a different. For example, somebody third person is enter into the network and is changed from H to C, hello to cello. So what is going to be happen? The C value. Why? How it is going to be confirmed means while decrypt the message itself, the receiver has to calculate their own hash again. So see that C value, what is the 3 and 5 plus 12 plus 12 plus 15. So out of these, I got the message digest value is 47. So now what is going to be happen? By comparing, see that? Okay. By comparing the message of digest each calculation, it is easy to determine that our message has changed. So obviously the hashing algorithm used in an example in full of flows. There is many words that when processed through the example, they might be result some digest. The original message may be, for example, here also we have some other problem. For example, if we are doing like this, if the O is going to be replaced by some T, what is the value of T? What is the number for T? So for example, the number for T is 15 plus O is 15. Yes or no? When O, P, Q, R, S, T. What is the next number? 15 plus, what is the value? What is the value for T? 20. So whatever, for example, if instead of sending cello, the third party person is entered CELLT, but the CELLT also resultant would be same as 52 only. Resultant could be given as the same also. That means, for example, instead of here O, we are going to be replaced by T itself. The final message resist 52 value is going to be get same. So here we have some. So and we have unaware that the original message had been altered. Are we- Yes, who is that? Number 88, please mute. Number 88, you're asking doubt or you're unwantedly unmute. See that? So if message is changed to cello, the resultant would be still 52, and we would aware that the original message have been altered. So in reality, in some hashing algorithm must maintain these qualities before approving the industry usage. So it is the actual process of message digest. So if some other cases also, may we have a message digest common value. So in order to overcome this, we have the industries will check this message digest. And for example, here in the Linux, they given an example. See that, for example, echo, we are giving a practical, for example, one. Now it is visible to everyone. So see that practical network.net. So we are performing MD5 sum. So we got it some value this one. So when we are changing that .net is the .net, in small n we are going to be replace the capital N even if the total message digest value is changed. So even one character is there, then the total value is changed. So how we are going to be perform? So for this one we are going to be do from some M operations we are going to be perform all those. So even we can just have an idea about this one. Now we have an idea about what is a message digest, what is the problems are in that message digest. Okay. Now we back to our original content. Okay. So this is the checking integrity. How we are going to be check the integrity? That only I told you know. So here it is not a reversible process. Message digest and hash algorithm is not a reversible process. So hash function is going to be performed on message, then we can perform message digest, then it is going to be transferred in the network. In other end, again the message digest value is going to be calculated. Then we are going to be compare whether it is S. For example, see, we are going to be condition. So if it is same, then message not being changed. If it is no, the message may be discarded. The message not going to be received by the receiver. Okay. So that is the simple. So a cryptography hash function must have safety three criteria. So primage resistance and secondary primage resistance and collision resistance. So these are the three safety methods we are using in hash function. So we will see one by one. So this one, first one. So listen, see carefully about the diagrams. By the diagrams itself, we can understand that what is the three different safeties. The hash function must have one-way function. So we know that a hash function is only one way. It is not a reversible process. For a given code H, it is conceptually infeasible to find H inverse. So it is not a reversible process. We cannot find H inverse. So what we can do here, we can just simply finding the hash function and we can perform the message digest. Then it is sent it. The receiver has to calculate again for received message, and he is going to be perform the hash through hash. He is going to be perform message digest value. Then both values are compared. Then we can confirm it. It is not a infeasible of we cannot find the H inverse. So here how it is. So M is the message and hash is the hash function. H of M is the digest. We are going to be see that message. On message we are going to be perform the hash function. Once we perform hash function on message, then it is known as a message digest. So that is y equal to H of M. That is a message digest. Then we are going to be sent it given by if find any M inverse, that is M transpose. So M something M transpose such that y of HM is going to be performed. So something is modification is done. It is not Bob. Alice is trying to send the message to the Bob. In between the network, the Eva is find the message and he is going to be changed. If anything changes happen in that, then definitely M is going to be changed to M dash something. So by this we can do the safety of it. First one, permeation resistance, how we can perform this. Second one, so can we use a conventional lossless comparison method such as stuff it as a cryptographic hash function? Solution, we cannot a lossless comparison method to create the comparison message. It is irreversible. Is a message is that reversible. We cannot do it, no. We cannot do it as a reversible process, no. So that's why only which letter is missed or which message is missed, we cannot find it. The second one is about second permeation resistance. How we are going to be performed here. See here, the same thing. So previous one, the message and hash we done. Finally, we got a message digest something value or something content we can. That direct H of M we are going to be transferred through the network. H of M is transferred to the network. So there here again M is going to be added to the message digest. M is going to be added to the message list. So in the network we are going to be send M plus H of M. That is a message plus message digest. Both we are going to be sent to the key. Then it is going to be transferred in the network. So it is going to be received by the Bob. If any changes is happened, then definitely M that message actually it has to receive H of M only. But if anything is changed in between, then definitely it is going to be M dash. So then Bob may reject that one. Then so here the third one is about so collision resistance, how it will be. So here M and message we both have. So we can find M and M dash such that M is not equal to M dash, but H of M is equal to H of M dash. So collision attack, something attack is happened. How we can find, no? By calculating the H of that is message digest, we can find out whether the collision is done or not, whether the attack is done or not. We can find out. By these three ways, we can find out whether message is safety or not. So first one is privilege, second one second privilege, third one is collision resistance. These are the three important concepts in hashing algorithm safeties. So we already saw about this message authentication in the last class. So we can overall once again we can see. So in the last class we discussed only about message authentication code only. So here they mentioned again one more thing is about modification detection code also. Modification detection code also. So two things. A message digest does not authenticate the sender of the message to provide the message authentication. Allies needs to provide the proof that it's the allies sending the message and it is not importer. So the digest created by the cryptography hash function is normally called modification detection code. What we need to for the message authentication, that is by a message authentication code we need to enter. So we are following the hash algorithm. Finally, we are going to be get the message digest algorithm. Even though we have a problem with whether it is confirmed that whether the sender is sending or not. We are not confirming that. Okay, so that is a previous one I showed no. So even if it is a 52 digest message digest, but we are changing some values also, we may get some other 52. Whether it is same or not, we don't know. So the how far we can authenticate that message in a proper manner. So for that we have message authentication code. So that what will be. So a modification detection code is a message digest that can be provide the integrity of the message. That message has not been changed. If Allies needs to send the message to Bob and be sure that the message will not change during the transmission. Allies can create the message digest along with the modification detection code MDC and send the both message and the MDC to Bob. Bob can create a new MDC. Again, here also it is not a process. He is going to be again creating a message modification detection code MDC from the message and compare the received MDC. The new MDC, received MDC and the new MDC. So new MDC which was calculated by the Bob. So the received MDC is sent by the Allies. If they are same, the message has not been changed. They can treat that message has not been changed. So see here. So insecure channel we are going to be sent. So channel immediate to change. So we may chance of changing. So how we are going to be sent? So instead of doing a message digest, we are going to be perform modification detection code. So once a hash function is going to be performed, here we are going to be create message modification detection code we are going to be sent. So same there how the message digest is going to be performed. Here we are going to be check with the modification detection code we are going to be sent. So same here the modification detection code is going to be checked the receiver end. So here the receiver is going to be calculated one and MDC is going to be come from the channel immediate to change. So if the both are correct or that is both are same or not. So maybe we can, for example, message is sent. How come we confirm that whether the message is sent by the exact one or not? So he may send some, for example, simple how we are going to be get the OTP, no? So OTP is getting the OTP which we send it that only we can enter that both comparison, then we can perform. If we enter something wrong OTP, what is going to be happen? It is going to be rejected. No? Same here. Okay. So then another one we have the difference between MDC and MAC. So message authentication code key, message detection code key, what is the difference between? So even if message detection code is sending, so how far we are going to be give that such that the Allies is sending the message by Bob, how come confirming that? So here, see that again the message and hash function and MAC, both MAC and message is going to be transferred. In between we have see here what is K. We are going to be used K. So whenever security key if we have to talk, so we have to deal with the two types, whether it is a symmetric key or asymmetric. Symmetric key means both are similar. Asymmetric key means both. For example, both are sharing the same key. In asymmetric key means one side using a public key, another side using a private. So maybe sender is going to be use a private key to encrypt, and receiver is going to be decrypt by using a public key. So that also is there. I will show you in the next slide. So Alice is sending a message and is going to be perform a hash function along with key. So here the keys are same. Here the keys are same. So is doing a hash algorithm along with the key, then MAC is going to be added. Now the message and MAC again sending to the network in secure channel. Now message and MAC is received, but message and by using the key which is shared by the Alice and Bob, that key is going to be performed on the hash and is going to be calculated another MAC, message authentication is going to be calculated by the Bob. So even if the Alice is sended the MAC, that MAC is here, that both are going to be check it whether the both are same, it is going to be accepted, it is not same, it is going to be rejected. So have you found the difference between MDC and MAC? Modification detection code key, message authentication code key difference. Message authentication code along with key we are going to be performed. In modification detection code we don't have any key, we can just simply perform hashing, and by the hash function we are going to be get message modification detection code. Okay, so MAC is security. How come we forget the message without having a key? If the size of key may exhaustive search, it may try for all the possibility keys to message, digest to message. Use the primitive attack. So the given some pair of messages and MACs, Kiva can manipulate to come up with the new message and its digest. The security of MAC depend upon the security of underlying of hash algorithm. So how come the security for providing for MAC means how much key size of algorithm. So maybe we come across about various size of keys. So even I will show you now. So underlying the hash algorithm. So see here. So we have a nested MAC also. What is a nested MAC? To improve MAC security, provide the MAC were designed in which hashing is performed twice. Nested is not that only, no. Nested if, nested for, nested while we are talking about if inside another if, for inside another for, we can call nested. Same here, the same key we are going to be performed 2 times. So that is known as nested MAC also we can perform. So up to this is about message integrity and authentication. Okay, message integrity and authentication. Then another one is about next hash function. Up to now we did about how we are going to be perform hash. Now what is a hash function? How it is going to be do in hash function? So a cryptographic hash function takes a message of arbitrary length and create the message digest of a fixed length. It is called an hash. So in the last class also we discussed. So after hashing, it is going to be have a equal length of fixed length. So even if, for example, it is a 1 bit also, the next one will be the 2 bits or 3 bits one. The previous one is going to be added before zeros. I told a concept now how we are going to be add the zeros while we are performing the operation. The same thing is going to be done. Once the message digest is confirmed with the hash, it is going to be have a fixed length of all messages. So the goals of hashing cryptography, iterated hash function and 2 groups of comparison of function. What are the 3 things we are going to be discussed on this? So hashing cryptography is used to provide the integrity to ensure that information has not been altered by unauthorized person or miscellaneous software. So maybe a software or a third party person is not going to be changed. So that is known as a middle man in the middle attack. man in the middle attack defected by hashing. So for example, for example, original plain text message, you are hired. So something in company, they send a message as, yes, you are hired. The hashing algorithm is performed. The you are hired is going to be converted into something number, what 5409835. So that is may have what is the number of you, not what is the number of O, what is the number of you, again space. Even if space also considered as a one special character, for that also we have a number, that also we can calculate it. Message is transmitted. So that middle, some person, some unauthorized person enter into the network. What he done? See that you are fired. Instead of hired, they changed into H changed into F. What is going to be happen? So total meaning was changed, and hash algorithm is performed. So now the receiver is finding that the message digest code is this one. Then the sender message digest code and receiver digest code is not matching. So who is going to be identify this one? So man in the middle attack defected by the hash. So the message and its digest are sent to the receiver to verify the integrity. So that is the combining, adding all those things, the letters are adding, that is the integrity. That integrity also we are going to be send it. So now if we send you are hired along with the message digest code, if both are sending, so when he calculated his own, even if the message was changed, then he is going to be compared with the original message digest code and receiver calculated message digest code. So that's why it is not a reversible process. Once again, I am going to be, so which is calculated by the receiver separately, then both are is going to be compared. Once it is going to be done, then we can verify this integrity. So see that characteristics: confidentiality, no; integrity, yes; availability, no; authenticity, no; and no reputation. Information protection by the hashing crypto. So it is only provided the integrity only. It is only provided the integrity only. So Markle damage schema. So it is here iterated hash function is there. How we are going to be performed? Iterated means repeating. How we are going to be repeated based upon the input size. So we have some H naught. So it contains some M bits are there. So for each bit we are going to be perform the compression of function. So M1 and M2. So on empty. So you know what is the padding and length? Where you heard about the padding and length? So when we are seeing about the message, how the message is going to be layered in, for example, what is the header of IP address? Header of IP address, how it will be, the IP address structure will be. So there we have a checksum, FAC, what is the size of the message, what is the length, whether it is checksum is calculated or not. Then we have a message, then the later we have an optional code, then later we have the another bit. So there we have meaning called padding. So all those things, information about the message. That message is going to be divided into different parts. Bit wise it is going to be different, and it is going to be perform the message digest. One bit is going to be decentralized and is going to be calculated the message. So H naught is the contains n bit, and HT is going to be finally calculated how many bits are there. That many bits the message digest is going to be calculated. So the comparison function is made for both message digest algorithm version. So three versions: MD2, MD4, MD5, and security hash algorithm SHA more secure than MD. Here we have two types: SHA1, secure hash algorithm 1, and secure hash algorithm 2. So patterned after MD4, but creates the hash that is 160 bits length instead of 128. So we can treat that, for example, we have some key is going to be used. The key is 128 bit before one. So in the SHA one, we are going to be use 160 bits of key we are going to be use. Compared to SHA 2, the comparison of 4 variants we known as SHA 224. It is a simple thing, but how many bits of key is going to be used there? 224 is there, 256 is there, 384 is there, and 512 also is there. So you can find out this MD4, but create the hash function as 160 bits instead of 128 length. So this is SHA1. In SHA2, we have again 4 variants are there. By using 224 bit key and 256 bit key and 384 bit key and 512 bit key. So this is the characteristics of each SH1. There we are going to be use 160 and remaining the name itself is there. So these are message digest size. So how many bits of length we are going to be. So that is once after finding the message digest, the total length will be 224. So that is the 224 bit of data is going to become out. So I already told you that hash function is performed, then the fixed length of output is going to be come out. So that is here 224 bits will come, here 256, here 384 and 512. So number of rounds here we are going to be perform 80 rounds, here the 64 rounds, here 64 rounds. So these rounds you can come across all the security algorithms are finished. Security algorithm, RSA, SHA, algorithms are finished or not? Can someone answer? So what size is here? The 32 bit size. Here also 32 bit, and here 32, and the last two we have 64 bit size. So here we have two groups of comparison functions. So asymmetric key block cipher serves as a comparison function. So a relatively recent cryptographic hash function has received the international recognition of adapting by the standard organization. It creates hash of 512 bits. So that is a simple example about how far it is giving a security with the 512 bits. So Rabin scheme, here we see that. So we are padded message with the T blocks. So we have number of 0 to some T blocks. So we see that we are going to be do encrypt along with the key. Along with the key we are going to be using. Same key, then we are going to be perform the message digest key. So H0 bit, H0, for example, H0 is the about original message. The original message is going to be divided into a number of bits. So that is a M1, M2, M3 and so on, MT. So finally we have HT of message digest some number M bits. For M bits, here also we will get M bits. So M bits of message, it is going to be divided into a number of bits. For each bit we are going to be calculated the encrypt and we are going to be send it back. So Davies-Mayer scheme. Here we have again we are performing some. What is the plus rounded symbol? What is the plus rounded symbol? What is the meaning called plus rounded symbol? XOR operation. What is going to be XOR operation? What is XOR operation? So here in a previous scheme we have done a different operation. What is the XOR operation? What is the OR gate symbol? OR gate. What is the OR gate symbol? It is the
ఏదైనా ఒక ట్రూ అయితే ట్రూ.
so exactly reverse of that one. Okay, so that once we have done for individual bit encryption, then we are going to be do the XOR operation in between them. So we have to provide some more security on this. So there we have XOR operations we are going to be perform and we are going to be send it, and finally we are going to get some message. So same here we have various schemas are available. So how come we are going to be perform? See that in the previous one we are going to be perform message digest, then previous one. Here we have to perform XOR operation for twice here, the same message and the received message. So that are the various. So up to this hash function and message digest we completed today. Tomorrow we will know about what is the digital signature. Okay, we'll deal tomorrow by digital signature. Still, anyone having doubt, you can ask me. What is about today? We were discuss about message integrity, and another one message authentication, and another one hash function. In that hash function, we were deal with MDC modification detection code and message authentication code. These are the four topics were discussed today. If you have any